Well, today we're going to solve a problem on this 1990 Thunderbird Super Coupe. It's been sitting in the barn for around 4 years and just got it pulled out, and it does not want to crank over. Starter doesn't do anything other than click. But it installed a brand new battery because the old battery was frozen and defective. So it's got a new battery in here, but it still does nothing more than simply click. So I need to come up with a strategy to approach this problem. So what I'm going to do on this one is I'm going to get my DVOM. So I've got my DVOM, and I'm going to use an amp probe. I'm going to approach this from a couple different ways, but I'm going to utilize the amp probe to determine if we have any current flowing from the starter. So first thing we need to do is we need to hook the amp probe up, and you can see in the back here there's a positive and a negative embossed into the plastic. It's critical that it's put into your meter this way. So we're going to go with common and then our volts. So now that we got it in there, we're going to turn it over to the millivolt range. And I am going to see, since I'm going to do the cranking, I'm going to start out in the 400 amp range, and I'm going to go ahead and I'm going to zero it. Seems a little hard to zero. So that makes me suspicious, since I haven't used it in a few months. Makes me a little suspicious that we don't have a deeper problem with the amp probe itself. So first thing, and that's part of the maintenance one should perform, is we're going to do a battery test. Well, things I'm going to need here for this battery test is remove the cover out, and see the condition of our battery. Well, first thing I can see is I got some corrosion on the battery, so immediately I'm sure glad that I used this now so I didn't have a battery corroding inside of the meter. Jump over here, we're going to turn it to volts, DC, and let's see what we got for a battery condition. Well, the battery condition is 8.79 volts, definitely getting on the low side of performance of the battery, so this is a discard. Kind of assuming we might have this problem, I went ahead and grabbed a brand new battery. So go ahead and place that inside. As you can see, there's not a lot of work in changing out the battery. Get it in there, we'll get it snug. Put the cover on there, make sure it snaps into place. You can see how nicely it zeroes out after having put a new battery in there. The old battery definitely made it more difficult to zero. So I put a little X on here to indicating where the positive the battery is going to be. So in this particular case, easy to get to the negative cable. I'm just going to hook up right there. And I want to see how much current we have, so I'm going to put it into record mode for max current. Okay, looks like we had about 40 amps. That's nowhere near a shorted starter or a locked motor, because there I'd expect to see 400 amp current draw. So in this particular case here, that was just simply the fuel pump, all the accessories turning on, and the, I guess we'd say, attempting of the solenoid to engage. But now we need to determine where our problem is. So the next approach I'm going to take is I think I'm going to go right to the S terminal, or the start terminal here on the solenoid. I'm going to switch over to the low current. I'll zero this out again. Okay, I got it pretty close to zeroed out. I'm going to go ahead and the current flow is going to come into the wire in that direction. So I'll put the amp probe on there. So let's go ahead and do our test. Okay, looks like we have around 3 amps of current draw coming into the solenoid. That's a very kind of lighter, on the lighter end of the current flow, but within the acceptable range. What I'm going to do is I'm going to do one additional test. What I'm going to do here is I'm going to use a 10 amp turn. This 10 amp turn is going to magnify the signal coming in on the amp probe by 10 times. So if you want to think about it very simply, there's 10 cycles or 10 strands of wire in a circle here, and that's going to magnetically increase. There will be a magnetic increase in the field by 10 times. So we know that this one here is going to be our power coming in. Okay, let's go ahead and we'll put it on record. Okay, we have a highly accurate number here. So we've got 2.8, we'll call it 2.86 amps coming into the solenoid. Well within the acceptable range, a little bit on the light side. So we know that the solenoid, it's got enough current coming in. We know that it audibly clicks. So obviously we got a mechanical problem in the solenoid itself. Okay, let's go ahead and do one more test. The next one's going to be a simple voltage drop across the solenoid. Make sure we turn it off so we start out next time with a good battery. We have our leads now for our meter. We'll put it on volts. And what my plan is at this point here is to take these, I sure like these leads, high quality silicone leads. So hook our meter up. And the reason you're seeing a voltage here is this is basically an antenna at this point. So just be aware that is a normal condition with a multimeter. It's picking up all the energy that's in the shop right at this moment. So what we're going to do here is we're going to go plus solenoid. Go ahead, we'll hook up to the cable here. And I'm going to go ahead and I'm going to crank it. So energize that solenoid, and what we're going to do is we're going to look for what we see as far as the max amount coming across here. So that means that solenoid's got to provide a ground. Okay, I'm going to put this in a record mode. Now I want to go ahead and I'm going to see what the maximum draw is across the solenoid. Well, that's sure nothing to write home about. We got about 0.5 volt, so obviously within the solenoid itself it's dropping excessive voltage. So the contact's slamming, but it's not doing any work. The next task is going to be is to remove the this old solenoid and let's get a new one installed. The step is to disconnect the negative cable. Okay, we'll get our harness and disconnect it. Now we'll take our new solenoid, a premium quality Napa solenoid. And make sure we have a good ground here. Connections, so the screw is nice and clean, there's no corrosion or rust. This is quite an amazing car, so rust free. Okay, we have a little spacer here to take up some of the space on this one, because on the other side we have all the cables that attached that keeps them even. Nice little feature that they have. And then we have an aggressive star washer to make sure we have a good mechanical connection. I'm going to put a medium amount of torque on here so we secure a good ground, but no chance of stripping. Okay, get her nice and tight, but not excessively tight. On the power wire, we'll put on the negative cable. Let's get the tools and the hardware out of here. Okay, now we got this all back together. Let's see what's going to happen. Success. Pretty straightforward. Got her fixed. Let's do one more thing while we're here. Let's go ahead and see how much current this draws. I'm going to put on the high amps. Make sure we include everything that's going to be coming off the battery. A little quick reminder here. So we'll make sure the plus and minus. Okay, let's go ahead and we're going to go ahead and now we got it hooked up. I went to the standard volts instead of the millivolts because I know it's going to be a lot of current. We're set for max. Let's go ahead and see what we have for inrush current. Okay, 150 amps. And we know a lion's share of that is coming from the starter itself. So I remember when we earlier tested it, we seen about 40 amps. So we can say that 110 of that is coming from the starter. That tells me we got good integrity down to the starter from the wires. We got a good ground on it. The engine turns over very easy, so that's good news. And obviously we don't have any drag inside of the starter because the current level is low, but it cranked over fine, started right up. So, hope you learned something from this section here. I guess we're going to be going on to another broken thing around here. I have a forklift that we're going to have to contend with. So we'll look and see what's going on there. Well, we got the forklift inside. Had to jump start it to get it in. I've let it run for quite a while. Extremely cold out there. And I've let it run for a while, so it should have charged up the battery. The battery, it cranked for quite a while, just would not start. And it cranked relatively slow. So we're going to look and see where the problem is. First thing I need to do is see what the status of the battery is. So we're going to check battery voltage across the terminals. Okay, we got 12.52 volts. That's a little bit low than I would expect it, but I did crank it to the battery was pretty low, so that doesn't necessarily mean that the charging system will be able to bring it completely back. Just started it, it started fine. Well, now to run this test, I'm eliminating its ability to start, so I'm using a remote start button here to crank it over. That way I can leave the key off. I don't have any propane running to it. So first thing we're going to do is we're going to give it a short crank. We'll give it about a 5 to 10 seconds. Okay, battery was a little lower than I'd like to see. 9.6 is the number that you don't want to see to go below when cranking. That is the bare minimum spec. And you can also see the bounce back voltage here was not very good. We're at 12.3, I guess we'll round it off to. And you can see it is recovering some, it's coming back in. Next thing I want to do is I want to see if the problem is actually at the starter drawing excessive current or the motor. So what we're going to do is we're going to put the amp probe on. Take note of the polarity again. We're going to go to the 400 amp scale because we're going to be cranking. Okay, current flow. We want a little mark here we put on the side at the plus side of the battery. That's located right here. And we'll go ahead and we're going to crank it and see what we have for current. So I see on an average about 225 amps. We could see what our peak. So we've seen 207 amps and that particular cycle. So it's not excessive. The engine's cranking, and here it's cranking slow. I'm not going to blame the starter or the engine at this point. I don't see a very problem. Either we have excessive amount of voltage drop down down there, and or we have a situation that we have a battery that's substandard. So that's going to be the next thing, is I'm going to go ahead and charge the battery. Okay, well, we are at a full charge, including a little bit of a surface charge. This is a standard flooded cell battery, not a AGM, and we got 12.73. So that's fully charged with a little bit of a surface charge sitting on top. So at this point here, I'm going to go ahead and crank it over, see what it sounds like. Oh, a little bit busier. It spins a little nicer. So what we're going to do next, let's see how much current we have. It does spin a little better, but still seems sluggish. And remember from last time, we had quite a lot of current. So what we're going to do is put it on the volt setting. I am going to hook up there. Okay, we'll go with that. Hook up the amp probe, and let's go ahead and see how much current we have. Okay, the current is about the same. So the current hasn't changed, so I don't see any dynamic difference in that area. So it looks like what we probably are dealing with here is the battery just a little bit on the weak side. Not quite perfect. Let's go ahead and one last little test here. So our current are maintained about the same value. Let's see what our battery voltage is. So we didn't put that much time in cranking. And we're about 12.57. So we did use a little bit up. Let's see what it looks like again. One more crank. Oh yeah. The battery's overall capacity is significantly reduced. And you can see here the recovery voltage is very poor. We're looking at 12.4, slowly coming up. That's relatively poor condition for this battery. Not terribly old, but it lives a rough life around here. So I guess the next stage is going to be putting a battery, new battery in here. And we'll see what it looks like after that. Okay, now we got the new battery installed. And let's go ahead and see what it sounds like. Let's see what the voltage is. Okay, this brand new battery, just took it out of the box there, took little caps off on it, and it's ready to give it a try. So let's see what it sounds like. Well, right out of the box, we can see we had very little voltage deflection. Audibly, we had a very good cranking speed. So let's go ahead. Next process is going to do is let's measure the current. Okay, and we'll get that hooked down there. Battery had the opposite side post, so we are going to adjust accordingly here. Okay, let's see what our current draw is going to be. Okay, I want you to take careful note. We saw very little current change. We'll go ahead and run that test one more time. Put it on max. So at about 200 amps. So we can see with the bad battery and the good battery, current stayed the same because we didn't deflect the voltage immensely, but we affected it enough that we got very low cranking speed. So I guess the last thing to do is to see what happens. Okay, we're up and running. Success. We've figured out what was wrong, put a battery in it, also verified a lot of other things along the line. So utilizing these tools as they're designed can take all the guesswork out. Sure, I could have shot a battery in it right away. I guess that would have proved it out. But it also had the expense of the battery if it didn't fix it. Now I had a battery around here that may not have had a home. So hopefully this information was good. I appreciate your time and have a great evening.